Okay, so when you have problems like we have on this sheet, so for example, log base 3 of 8. What's the problem with that? Well, if you do 3 to the first, you get 3. If you do 3 squared, you get 9, right? Well, what's in between 3 and 9 is 8. There's no, it tells you that the exponent must be a decimal, right? And so there's a lot of questions like that. Somebody want to come up with another one you couldn't do by hand? I started out log base. Okay.
Just do log of any number that isn't 10 to the 0. Like you just say like log of 19.
Okay, log of 19. Log base 19 of.
I was just thinking like log base 10 of anything that doesn't end with a 0.
Okay, yeah, log base. Okay, I got you. Log base 10 of 11, right? There's no way to figure that out by hand, right? It would be 1 point something, right? It wouldn't be 2, because 10 squared is 100. It wouldn't be 1. It'd be somewhere between 1 and 2. All right, or this one I just wrote, log base 19 of, say, 2. You would need change of base formula for that. That's what we'll teach you. All right, so the way the change of base formula works, well, here's some more examples. You don't have to write this down, but we'll talk about them, each of these. Log base 6 of 9, why can't you do that by hand? Because 6 to the first is 6. 6 squared is 36, so it's between 1 and 2, some decimal. Okay?
Oh.
7 to what power gives you 48? Well, it would be almost 2, right? But 7 squared is 49, so it'd be a little bit less than 2. Again, you can't do it by hand.
So then it's when you do it with the calculator.
So then this is where we use change of base formula, and I'll show you how it works.
Okay.
When you cannot evaluate a logarithm by hand because you can't find a common base, you must use the change of base formula and plug into your calculator. So I will show you how to do that real quick. This is a little proof. Let's say y equals log base b of x. So in our example 10 and 11, for example, where we can't solve it, we can convert this to an exponential, b to the y equals x. The next thing we're to do is take log base a of both sides, so a different base. Okay? A different base other than b, that's what's called change of base. So we can do that because we're doing the same thing to both sides of the equation. Now, there's a rule I'm going to teach you in a minute, maybe tomorrow. We've talked about this rule before. When you have an exponent inside a logarithm, you can take the exponent and move it out front. So you get y log base a of b equals log base a of x. Can anybody tell me from here how you would get y by itself? Well, what does y log a b really mean? What's this? It's multiply. Yes. So you would divide both sides by log base a of b, and that's how you get your change of base formula. Again, you don't need to copy that down. It's just a proof. When you divide both sides by log base a of b, you get y equals log base a of x over log base a of b. So what that means is you can simply change your base to any number a and plug in x for the first log and b for the second log, just to give you some insight. Basically, you're just going to do log of this number inside the log divided by log of the base. So for example, the 10 and 11, the way you would plug that into your calculator if you're doing log base 10 of 11 would just be log of 11 divided by log of 10. So it's just whatever's inside your log divided by log of whatever the original base was. So let's do some examples to make more sense of it. Yeah, let's just go to log base 7 of 9. Okay, so the application of this is really, really easy. See how 9 is inside the logarithm? First thing you're going to do in your calculator is plug in log of 9. Okay, does everybody see that the base is 7? The second thing you're going to do is divide by log of 7. And then once you type that in, it's going to give you what log base 7 of 9 is. You said 7 to the first is 7. 7 squared is 49, so we know it's going to be between 1 and 2. And I'll show you how to do that. It's real easy. Okay, any questions about plugging that in? Log 9 over log of 7. Okay? 1.129. Again, you know it's got to be between 1 and 2. Round to 3 decimal places. All right, let's do another real quick. Log base 7 of 48. Can you sit down, please? Oh, you're helping her?
Yeah.
Okay. Let's do this one. Maybe it'll make more sense. We're going to type in log of 48 divided by log of 7. Now I'm going to show you guys something. You don't have to use ln, but ln works the same as log because it doesn't matter which base you use. You could use any base, and you're going to get the same answer, and I'm going to show you for this example. So we'll do log first, and then we'll do natural log, and you'll see why you get the same answer. So I'm going to plug in log of 48 over log of 7. Okay, and I get 1.989. Now, watch what happens when I use natural log. I'm just going to type in ln of 48 divided by ln of 7. I get exactly the same thing. With the way the change of base works, it doesn't matter which one you use. You're going to get exactly the same answer, 1.989. Any questions about that? So this is how you evaluate logs with your calculator, and again we do it because you can't do it by hand.